Hello, and today's learning target is I can use scientific notation to rewrite big and small numbers. Another learning target of this video could be, I can rewrite scientific notation to standard form, and I can write standard form to scientific notation. So rewriting numbers into different forms, as well as what we'll look at. We will also look at what does it mean to have scientific notation in your calculator. And what scientific notation is it's a method to write a very large or very small number in an equivalent and cleaner form. And you may have heard about this in some of your other classes, maybe science class, but some examples could be 3.2 times 10 to the third, 4.9 times 10 to the negative fourth, negative 9.542 times 10 to the negative ninth, negative 2.52 times 10 to the ninth. So you're probably seeing, or you're probably getting an idea that scientific notation has times 10 to a certain power. And these are what we call powers of 10. They make a number really large or make a number really small, similar to thinking about place value. And that's one characteristic of scientific notation. Another characteristic is that your first term, the first number written, so here 3.2, 4.9, so on and so forth, has to be a number between 1 and 10. It could be negative, so between negative 1 and negative 10. But the decimal is always after the first number. So 3.2, 4.9, negative 9.542, right? So you only see one digit in front of that decimal. It doesn't matter how many digits we have after the decimal, but we can only have one in front. And so that means it needs to be between 1 and 10, but it can't be 10. So I maybe said that could be between 1 and 10. Can't be 10. So it's really, 1 to 9.9999, could go on forever. But it's between 1 and 10, can't be 10, right? Because if it was 10, we could write it as 1.0 something, right? So it has to be a number between 1 and 10, or again, it could be negative, so anywhere between negative 1 and negative 10, without being 10, but it can equal 1. All right, let's practice rewriting the following numbers in scientific notation. So here we have 201 million. So I see the decimal is really here at the end of that 201 million, but I want that to be right after the 2, so I need to move that right there. So let's count how many place values that would take. 1, 2, 3, 4, 5, 6, 7, 8. And that 8 will play a factor here in a moment. So I have 2.01, so I have to write my first number in scientific notation until I get to the rest being zeros. So here it's 2.01, then there's all zeros after that. So my first term in this scientific notation is 2.01 times 10 to the 8th, because I had to move 8 place values over from where it was originally. So we just wrote this big number, 201 million, as a smaller term, 2.01 times 10 to the 8th. So if we were to take 2.01 and move the decimal over 8 places to the right, 1, 2, 3, 4, 5, 6, 7, 8, fill these place values with zeros, we would in fact get back to our 201 million. Let's look at the next example. So here I have zeros in front of this 5 and the 1. So this is a really small number, whereas the last number that we looked at, 201 million, was a very large number. So that will have one slight difference in how we write our scientific notation. So here I want the decimal to be after the 5. So I'm going to move the decimal over 1, 2, 3, 4, 5 places to the right. So my first term will be 5.1 times 10 to the, now since we moved our decimal to the right here in this example, this previous example we moved it to the left, since we moved it to the right here, that means my number is actually really small. So I need to put negative 5 as my exponent, because if I were to rewrite this, 5.1, if I have negative 5, that means I really go to the left when I rewrite back to standard form. So if I move my decimal 5 places to the left, fill in those place values with zeros. Did I get that original answer? You bet I did. So when I have really small numbers, that means there are zeros in front of my first number that's not a zero, as in the second example, I have a negative exponent. When I have a really large number with lots of zeros at the end of the number, that has a positive exponent. Okay, let's look at this next example. I have 6.87. Now if I start at the end here and count back the number of place values till I get to 6, or the decimal right there, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my answer will be 6.87 times 10 to the 10th. Again, I could make sure I'm right by rewriting the scientific notation back to standard form. However, we just did that on the last two examples, so to save a little time, I'm going to go ahead and go on to the next example. Okay, so now here with the 7.25, I'm going to count back how many places I need to move. 1, 2, 3, 4, 5, 6. So 7.25 times 10 to the negative 6th. That'd be my answer in scientific notation. All right, now let's look at a couple examples where we'll rewrite the following numbers to standard form. So standard form is just the number written how we normally would see it, not in scientific notation. So here I have 6.32 times 10 to the 9th. So if I write that out, so I had to move 9 places to the left to get my answer. So now I'm going to undo that and move the decimal 9 places to the right. So I'm going to get a very large number. So here I go. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. Fill in with zeros. And I'm going to rewrite my answer so I can better see what this is. So there's 7 zeros there. So I'll put a comma after every 3 places. And this final answer would be 6,320,000,000. So again, a very large number. All right, now let's look at this 4 times 10 to the negative 7th. So I have 4 with my decimal after it, so I'm going to move to the left 7 place values. 1, 2, 3, 4, 5, 6, 7. So that's 6 zeros in front of the 4. So if I rewrite my final answer, again, it's always proper to write 0 point. So when you have a decimal, it's always important to write the 0 in front of that. So 1, 2, 3, 4, 5, 6, and then there's the 4. So if we were to say this, in the correct term, this would be 4 10,000,000ths. So it's a very small number. All right, let's take a look at a few more. 3.201 times 10 to the 6. So here I have 3.201. Let's move that place value over 6. 1, 2, 3, 4, 5, 6. So I'm going to add 3 zeros. So I get 3,201,000. I get 3,201,000. All right, 9.03. I'm going to move the decimal 5 places to the left because it's a negative exponent. 1, 2, 3, 4, 5. So that's 0.4 zeros in front of that 903. And that would be my final answer. So again, a small number. All right, now we're going to talk about some different calculator displays. So after doing a calculation, your calculator may display the following images. We'll write each number in scientific and standard notation and determine what your calculator would be telling you based on what you see here. So with this first example, 1.5, negative 10. That really means, in scientific notation, 1.5 times 10 to the negative 10th. In standard notation, that means there would be 9 zeros in front of that 1. So what I could do is, when I write this out, I would write 0 point with 9 zeros. And that would be standard form, which is a very small number. And this doesn't fit in some calculators display, so that's why it'll turn it into scientific notation right away, into that 1.5 and then just a negative 10 following it, written smaller. So with this next example, negative 8.12 times 10 to the ninth. That is already written in scientific notation, and maybe you already could tell that. So that really just means negative 8.12 times 10 to the ninth. And in standard form, that would be negative, and I'll write 812, and that would follow with 7 zeros because 2 places with the 1 and 2 already take up 2 place values. So then 2 away from 9 would be 7, so 7 zeros. So that would be a very large number. And again, that can't fit into the calculator display of any calculator, so that's why it will already translate that answer into scientific notation. Now with this last example, this says negative 7.21108 E7. That E is a shorthand notation for times 10, so that also represents scientific notation. So this would be negative 7.21108 times 10 to the 7th in scientific notation. Written in standard form would be negative 7.21108, and so if I move that decimal over 1, 2, 3, 4, 5, need to still add 2 zeros. So this would be negative 72,110,800. So again, that represents scientific notation, that E, short for times 10. Thanks for listening. Have a great day. Bye-bye.